Okay, so this one doesn't look like the others that we did because you only see one set of parentheses. But it is still technically multiplying a polynomial. Now notice that we have this outside exponent, which we did not have before. This squared is applying to the set of parentheses, saying that I need to write this out twice. If you write this out twice, then it will be our traditional binomial times a binomial. Now some of you might be saying, well, can I do this as the power rule? Can I just say that's 16 and that's 81m squared? Because this is a binomial, you are not allowed to do this as the power rule. Power rule only works with monomials. Okay, so make sure you realize that this is a binomial. So when you have a binomial or a trinomial with this exponent, this just tells you how many times to write out the base. Remember, the base is the one item that it touches, which is the set of parentheses. So I write out the base twice. Can't leave them naked, so put in 9m minus 4 in each of the parentheses. And now you can clearly see, it's a binomial times a binomial, which I can draw a rectangle. Even though it originally didn't look like a rectangle problem, just remember, if you see square or cubed, write it out that many times. So we're going to draw our big rectangle like we've been doing. This one, again, 2 by 2. So there's my 2 rows. There's my 2 columns. Because they're the exact same thing, it doesn't matter where you put them. 9m minus 4 and another 9m minus 4. Make sure you bring over the signs. And then 9 times 9, of course, is 81. M and M, one on top, one to the left. Add them. That's how we get 2 of them, or squared. Over here, negative 4 times 9 is negative 36. No m plus 1m, you still got 1. Same ordeal here. Negative 36m to the first. And then negative 4 times a negative 4, you know 2 negatives is going to be a positive 16. Now, like terms, I said, for the most part, will line up diagonal for us. So 81m squared, no other m squares, so you're done here. Single m's, m to the first, m to the first. These are like terms. Now, unlike the other one, notice this is a negative, and this is also a negative. So because they're 2 negatives, we add. The other problem that we had was one positive, one negative. They were additive inverses, they cancel out. But these two are 2 negatives, so we must add them together. This is how we get a negative 72, and then m. And then our constant term will always be written last, positive 16.